Okay, let's start. So today we will have the first lecture on introduction to computer engineering. So my name is Lee. I'm from the ISE department. So we will heavily use the Canvas. You can check all these information, including the office hour, on Canvas. Particularly if you want to have an office hour slot, you can just email me so that we can schedule a physical or Zoom office hour slot. So in this lecture, in this course, we will cover some very basic knowledge of the circuits and the computer and the different components of the circuits, including the decoder, encoder, adder, multiplier. We will also introduce how to use the Boolean algebra to build these circuit blocks. So we have a task book. You can actually download that on Canvas. Particularly, we have a syllabus on Canvas, which will contain the information of each lectures and the the recording of each class syllabus. So we will have 2 lectures. Sometimes I will change per week. Sometimes I will change the second lecture as a library, as a lab, so that you can do your own projects or homework. So traditionally, we have students from different backgrounds in this department. We have a physical, we have students from a physics department. We also have some students from economic department. So, so this is a very simple lectures. We only introduce some very basic circuit block. So you can consider this course, and the aim of this course is to teach CS or physics students to write VHDL. Sometimes we even teach students from biology to write some VHDL. So we only introduce some very simple and basic VHDL knowledge. And then you can use these simple knowledge to write some simple projects, which can be related to your biology or economy projects. So I hope that these knowledge of hardware design can help your research or your own research. So we will talk about some logic gates, truth table, Boolean algebra. So for example, you can, this is what we all have in the first half. In the second half, you can design some projects. Particularly, you can define some project related to machine learning. So after you select a topic, I can send you some papers, so we can discuss those papers, and you can write a simple circuit to accelerate some applications. Machine learning is just one example. You can choose other topics. So we have no examination in this class. We have homeworks. So after we introduced Boolean logic, Boolean algebra, some basic logic gates, you can implement those gates by VHDL. So these are the homeworks. and then you can write your own projects. You can even find a partner to do your own project. So again, I hope this lecture can give you a basic understanding on the connection between the circuits and the software. So at the end of this lecture, I hope that each of you can build some very simple computer system composed of some circuit components connected by wires. I hope that at the end of this lecture, you can have some very basic understanding on the logic design. So the computer engineering is actually the design and the implementation of some computer systems. It includes both the hardware design and software design. Because in a system, you need to have software and hardware. For your projects, you can emphasize on the hardware part and all the software part. But you have to implement some circuits to do that. So in order to do that, you have to understand the, of course, the application, which is the computer science part, and then you have to, you have to be capable of writing some circuits by VHDL. So that's the hardware part. So after you have this class, you can continue to these many directions. Or you can apply our PhD program, assuming that you are a master's degree student. So in this lecture, we will cover Boolean algebra and the algorithm that can simplify the Boolean algebra. By simplification, of course, we can reduce the area and the power consumption. And then we will also cover how to encode the numbers, binary, hex, and the decimal. And then we will introduce some very basic component of the circuit, including the decoder and the encoder and flip-flops. So here is some example. So in order to represent 0 and 1, we can use voltages. High voltage means 1 and a low voltage means 0. You can even use a switch to indicate 0 and 1. When the switch is closed, it's on, so it represents high voltage. When the switch is open, it's off. It represents 0. And then we will have some Boolean algebra operation on these variables, which can be 1 and 0. In order to do that, we will have some gates. This is one OR gate, one OR gate, 2 input OR gate. So it will conduct a OR operation between A and B. A and B can be 1 and 0. And this table indicates the truth table. It includes all the possible combinations when, with different inputs. So A can be 0 and 1, B can be 0 and 1. Because we have 2 variables, so we have 4 rows, 2, 2, 2, which is 4 rows here. We will also cover the timing part. For example, in this cycle, we provide a signal of A and a signal of B, and we generate an output here. And of course, we can change the signal of A and B in another clock cycle. So if you only have one cycle, that's combinational logic. If you have a clock, multiple cycles, it's a sequential circuit. So this is a AND gate, 2 input AND gate. Here is the truth table, and here is the timing part. And here is one example of a NOT gate. Because NOT gate has only one input. So we only have 2 of those here. And these timing diagram are ideal case. In this lecture, we will also consider the physical limitations, which means that after you decide to change your input, you have to pay a little delay here. So after this delay, only after this delay, you can generate the output here. We will also consider the physical limitations here. Any question? Because of the pandemic, you can choose to have this lecture online. No problem. I post the link on cameras. If you have any question, please email me. So this is the simple class because we have students from different backgrounds. Not everyone have studied these things in their undergraduate degree study period. We will introduce some very simple, very basic knowledge of the circuit. And then at the second half of this lecture, you will do your own projects. You can choose the topic of your projects. We will talk about that after maybe 4 or 3 lectures, so that you can have time to plan the topics. Any question? If no question, we can stop today. Thank you very much. Thank you.